This video is meant for Mrs. Rose's AB Calculus class on mean value theorem. The mean value theorem states that if f of x is a continuous function on an interval from a to b, and differentiable on the same interval, so there are no corners, no cusps, no vertical tangent lines, then there must be at least one x value on the interval where the instantaneous rate of change equals the average rate of change. It's important to remember what the vocabulary means when you're considering this definition. What is instantaneous rate of change, and what's the average rate of change? The instantaneous rate of change equals the derivative. The average rate of change equals the slope. So usually we use the y2 minus y1 over x2 minus x1 formula. But it might be easier to think about it as f of b minus f of a over b minus a. We're just calculating y values and plugging them in over x values. When you're trying to apply the mean value theorem, it's important to be able to determine whether the mean value theorem can be applied over an interval. To do this, you first need to evaluate the average rate of change. Then what we need to do is take the derivative of f of x for the instantaneous rate of change and set the derivative equal to the average rate of change, and then solve for x. So first we're going to look at the skill of determining whether a function can have the mean value theorem apply to it, and then find the values where it does apply. So if we look at b of x, the problem with this fraction is that the denominator is going to equal 0 when x equals 3. That's on the interval, so the mean value theorem does not apply because it's discontinuous on the interval. Now let's look at k of x. K of x is discontinuous at 0. However, that's not on the interval, so it works that it is continuous and it is differentiable. Now we need to evaluate the average rate of change. So I'm going to evaluate f of 2 and f of 1/2 and put that over 2 and 1/2. When you plug these into the calculator, you should get 3/2 minus 3 over 3/2. When you do that subtraction, this is going to be negative 1/2 or negative 3/2 over 3/2, so this answer should be negative 1. This is the average rate of change. The next thing we need to do is calculate the derivative. So since this is a quotient, we're going to use the quotient formula. So we have 1 times x minus x plus 1 times 1 all over x squared, which reduces to negative 1 over x squared. Finally, we need to set the average rate of change equal to the derivative, equal to the instantaneous rate of change, and then solve for x. So negative 1 is going to equal negative x squared, or 1 equals x squared. And then when you take the square root of both sides, you're going to get positive negative 1 equals x. So if you look at your interval from 1/2 to 2, the only place that really works is positive 1. So we can say that f prime of x equals, f prime of 1 equals the average rate of change from 1/2 to 2. And that's all we have.